All right, so today I'm going to talk to you about literate reverse engineering. This is a bit of a technical lecture, but I will not be doing an IDA demo or that sort of stuff. Specifically, I want to talk about what to do with a reverse engineering project after you've done the easy part, after you've gotten your feet on the ground, after you know what your target binary does, you've identified some of the functions in it, and now you want to start reverse engineering at scale. You want to begin targeting more than one version of a given application. Or you want to do reverse engineering as a team rather than as an individual. The workflow that IDA Pro teaches you to sit down, to begin identifying and naming functions, to begin commenting the code, that works very well for small samples. That works well when you have a little bit of code that you need to work with, but you don't have mounds of code. You don't have lots of different versions. You don't have things moving beneath your feet. And you don't collaborate with people. As soon as you want to start working with someone else, IDA's workflow becomes strangling. The databases don't support diffing. So as you make changes, you lose track of what the old versions did. You can save backup snapshots of your database, which is almost as good as undo. But it's not really the same thing. And then when you share your IDA Pro database with someone, like let's say you're working on a project and you invite me to join you on it, and you send me your IDA database and I open up that database. If I'm lucky, I get a couple of named functions and you can verbally tell me which I should care about. If I'm unlucky, I get an error message telling me that the jerk who made it never bought a legitimate copy of IDA and that the database is blacklisted because of the serial number that authored it. We can do a lot better than this. We can build reverse engineering projects in the same way that we build software projects. We can do it with text files instead of databases so that we can do diffs between them. We can manage these in version control so that the version control will allow us to have changes between multiple authors without stepping on each other's feet. Through emulation and unit testing, we can make sure that we don't break things or that we don't regress and break things that used to be working in our patches or in our understanding of a program. Through emulation, we can do this even for embedded systems hardware without having to physically tie that hardware into the loop. This also allows us to do some nifty things like use different tools. Because once you're using proper text files to record what you understand about a binary, you can write a script in half an hour to add support to your favorite reverse engineering tool for this. So if you use IDA and I use Binary Ninja and he uses Hopper and she uses Radara 2, we can all work on that project together without conflicts. If a couple of tricks are used. Now, some of what I'm telling you today is are things that I've successfully implemented in projects. A few of the other things are things that I wish I had implemented and would have saved me a lot of time if I'd done them right from the beginning. So in much of this, like, do as I say and not as I do. And there will be no IDA demos in this entire lecture. So if you're already looking for the exit, you'll be fine. I'm not going to be moving the mouse around. And this cat's name is Mimine. Julian Veneg stole her from me. If you could please get on your cell phone, and if you know Julian, if you could tweet, like @Julian Veneg, please give Travis his cat back. She'll be in plenty more slides. You can do it repeatedly every time she comes onto the screen, and then I'll get my cat back. Okay, so before we talk about how things should work, let's take a moment to think about how they do work. We'll have a fictional reverse engineer named Bob, and Bob is reverse engineering something. And he opens it up in IDA, and he gets this handy little screen that's going to help him do the day. Have any of you done programming with Visual Basic 6 or with like a Java integrated development environment? And you've noticed that it kind of like puts a stranglehold on you. Like you don't remember the names of your functions because the autocomplete will take care of it for you. You don't worry so much about ensuring that everything will build from the command line because it builds fine from the GUI. IDA and other CAD programs and integrated development environments, they sort of do this by necessity, because that makes it a lot easier to begin using them. If IDA did not have the startup screen that would allow you to select your opening document, if it didn't automatically recognize the functions for you by running the autoanalyzer first, it would be a lot harder to begin using it. But these same things that make it easy to start can sort of work against us later on. So Bob is reversing alone. He has one machine, he's bouncing between different functions, and he's giving them names, and he's adding comments, and he's naming variables. But all of this information is wrapped up in his own IDA database. It begins sort of like this. He has a bunch of bytes, he has a bunch of addresses, and then he slowly begins giving structure to this. He begins naming things, he begins figuring out which functions call which others. And early on, you have to do it this way, because early on, you're completely lost as to what your target program does. You need to figure it out for the first time before you begin to try and make your reversing cleaner. And throughout all of this, there's an end goal to do something with the program. You don't reverse engineer programs because C compilers generate good literature. If you did, we'd all buy them as paperback novels, and Sudoku would be out of business. Instead, you're trying to do something with it. You're trying to patch it, or you're trying to write an exploit for it, or you're trying to reverse engineer something that it interacts with. So as Bob goes through it, he's aware of this, and he'll focus on the pieces of the code that he cares most about. For example, if he's trying to break the copy protection on a video game, he'll begin looking for the code that actually validates the serial number. And that might be the only thing in megabytes upon megabytes of code that he actually cares about. Now, collaboration sucks in this environment because he's making notes for his own use. The function names that he gives make sense only to him. There is nothing when you open an IDA project that tells you which function you should read first. There is nothing that tells you which ones are more important than others. They might have comments, they might have color codes, but there is nothing higher level. And if he passes you this file, well, you get something that looks like this. You have a bunch of functions on the left, you've got the code in the middle, you have no idea which piece of this is valuable or relevant. And you won't have it unless he documents it elsewhere. And then you get this delightful error message telling you that Bob never paid for his license of IDA and ripped off an older version. And you get this even if you pay for IDA. So even those of us who purchase it, and you should purchase your tools if you're using them professionally, have to maintain like archives of old ripped off IDA versions or little scripts to patch out the serial number in order to bless a library or a database to make it legal to open. This is ridiculous. There's no reason that we should be communicating our reverse engineering in such a primitive way. So, and again, write to Julian Veneg and tell him to give me my cat back. So, what are things that we can do better? Well, the first stage is the triage stage. When Bob is initially reverse engineering his target, he needs to figure out which functions are worth caring about and which are not. And he'll begin by giving things names that are guesses. And he also gives things names that are facts. One of the problems with IDA is that it doesn't allow you to cleanly distinguish between guesses and facts. So as he gives everything in the target a name, when I try to look at his own notes and compare them to mine, there's no standard way for me to know that he absolutely recognized the printf function here, but he just thinks that like math thingy number 25 has something to do with math. By explicitly labeling these, you can better combine, you can better strip out your guesses in order to only share facts with someone else. Or to at least share them separately so that the collaborating reverse engineer can view the hints but never trust them. There's also this, this concept that you can sort of automatically label things by scripts. So in this image, if you have excellent eyesight, you can see in the top left, the functions in this image haven't been named yet by manual reverse engineering, but they've been categorized by what they do. So functions which have been identified through as like parents that are not found by the autoanalyzer, but that were found by a secondary script have been named with the name parent. Interrupt handlers have been named with the prefix vec, because they're in the interrupt vector table. Once you begin to keep your guesses separate from your facts, you're free to automatically label everything with a guess, and then overlay your facts on top of it in order to have somewhat meaningful names for everything, right from the beginning. So for each symbol that you identify, you should keep straight in your own head and also in the symbol name whether it's a guess or just a fact. Put _G before the end of every symbol that's a guess, and then you can grep to remove all of them, leaving just your facts. Because when I'm receiving reverse engineering work from someone else, I want to see all of that person's hunches, all of his guesses, but I don't want to link against them. I don't want to trust them or make them a functional part of my program or my patches or my exploit until after I've verified them. And again, Julian Van Egg should give Mimine back to me. So another trouble is that comments are not documentation. When you're in IDA and you're reverse engineering a function, you can apply comments to individual instructions, but you're not able to provide higher level documentation. And it's common as a working reverse engineer to be prejudiced against the higher level documentation because at the low level, you get things done. That's how you see how a function works. So some examples of high level observations that are of immediate practical value for reverse engineering from a specific project. So when you have a function that's produced by, when you have a binary that's produced by a C compiler, generally a C compiler, a C program will be built up of separate modules which are then linked together. So this organization of which module contains which functions will actually survive into the target application. So in the case of the MD380 firmware, the entire graphics library is held between a start address and an end address. And every function in that region is a graphics function. Once you begin to separate your guesses from your facts, you can run through and you can automatically label every function in that range with the prefix GFX. You don't know what it does, but you know that it does something involving graphics. Then later, when you see another function that calls a function beginning with GFX, you can then know that it's displaying something on the screen. Maybe it's drawing a box, maybe it's displaying text, maybe it's an icon. You don't know what yet, but of all the child functions that you might care about, you can immediately separate out the ones that involve graphics. In the same firmware image, the only function pointers that are ever used for any reason at all in the entire program are in the callbacks from the USB stack and the callbacks from the menus. So wherever you find a function pointer, for any reason, you know that you're dealing either with USB code or with the menu code. You can automatically label functions that involve those two, and then separate them out into regions and label entire chunks of the firmware with a rough guess until you go back and then find the absolute facts of which function handles an incoming USB packet or which function draws text to the screen. There's also this feature that on thumb, any function which both calls a child function and also returns begins by pushing the link register onto the stack. At the same time, all functions that are called directly, as in not by a function pointer, they all are accessed by the same instruction, which is BL, or branch and link. So if you run through the firmware image and you look for anything that pushes the link register onto the stack, you get many locations that are legitimate entries to functions. But you also get false positives in data that just coincidentally look like they're pushing the link register to the stack. Similarly, if you look for all branch and link instructions, you'll find many that are real and many that are false positives. But if you know that almost every target of a branch and link begins by pushing the link register to the stack, you can look for branches that go to a relative address that begins with the instruction that a function ought to begin with, and this allows you to automatically identify 95% of the functions in a large thumb2 program in a single sweep to immediately throw them into the autoanalyzer to recognize all of their children. And these high-level observations are not true for every program. They won't be true for obfuscated programs. They won't be true for heavily inlined programs or for programs where the programmer was lazy and threw everything into a single C file. But they're true for a lot of programs. And by verifying that they're true on your individual target and then scripting them, you will be able to automatically label large chunks of your program and to reduce the labor of reverse engineering it. And you should write up these discoveries. So for the MD380 Tools project, which is a ham radio that we reverse engineer, we have a wiki that describes how these things work. There's a wiki that describes how to load all of the symbols up into IDA. There's another one that tells you how to load everything into Radara 2, and a third that tells you how to load everything into Binary Ninja. By having this document, by writing it down, you then understand it better, even if you're not sharing it with anyone, even if it's only for your own benefit. And in addition to writing these things as text, which a human being should read, you should also write them up as scripts, which are to be run. And you should run these scripts by continuous integration. You can have a Jenkins or a Travis CI server that will run through to verify that your results work for multiple images, for multiple targets. And again, Julian should give Mimin back to me because she's my cat. Nadia Sitsavan. Now, getting back to collaboration for a minute. And I don't mean teamwork as in like we're going to do trust fall exercises and we're going to hug each other at the end and we're going to do the corporate retreat stuff. Teamwork is just that you need multiple reverse engineers working on a single target image without pissing each other off and without stepping on each other's shoes. It doesn't have to be a kumbaya thing so much as not actively undoing each other's work. If you try to do a reverse engineering project between many people with IDA by sharing an IDB database, very quickly one IDB fork will become the best one and all of the others will be thrown away. and you'll have excellent records for the USB stack, and you will have completely lost all of the graphics code. So the key to doing this properly is to use text files and scripts in version control with continuous integration. By having text files that describe your symbols, their addresses, that can be grepped to separate whether they're a guess or a fact, to have comments to indicate who added that symbol or who last modified it, so that you can then know which member of your team is most familiar with a particular function, who gave it that name. And then CI tests to verify that this works for more than one version of your target, so that you can port your code automatically. When I'm reverse engineering the MD380 and I identify a new function, I'm not going to repeat that work for 9 separate versions of the radio firmware. Instead, I wrote a symbol porting tool that automatically converts the symbol for me, and a continuous integration script that will verify that the important functions are available in all of the versions that I care about. Now, the best thing about text files is that they're already supported by all of the major reverse engineering tools, and you can convert them by shell script. GNU-LD is nice because it can be directly used by the linker. So as you're patching code, you can automatically throw all of those symbols in and then call the function as if it were a regular function. IDA Pro and Radara 2 have their own formats. What I particularly like about Radara 2s is that, because they're the same as the command line, you can just paste them into an active session and then immediately have those symbols available. You should pick one file format, and you should give it good file names from the very beginning, in the same way that you would organize a programming project, so that you can then import only the symbols from the region that you care about. If you are working with a very large program and you're reverse engineering a piece of the USB code, it's sometimes very handy to only import the symbols for the USB stack and for like the one crypto library that it calls that you care about. Because then all of the labeled functions are related to your immediate target, and your call graphs are small. You don't have lots of noise that interferes with your effort. And you should have example scripts for importing these files into each of the major reverse engineering tools. There is no reason why we should all have to use the same reverse engineering tool, even if we're working on the same target project. This is also like a good way to get your money's worth for the IDA Pro license without excluding teammates who use different software. These are real symbol entries for items in RAM from one version of the Titera MD380 firmware. So these match into a core dump, and then by loading them up, you're able to view what the values were at those addresses, or to recognize any function that interacts with the data at that address. This is in Radara 2's format, but these were originally found in IDA. And it's really simple. You just have an F, and then you have the symbol name, and then you have an @ and then you have the address. Anyone who has been programming at for a couple of months, who can do string processing, who can do sed and grep, can work with these sorts of files. A quick little Python script will import them into any of the modern reverse engineering toolkits. And then it doesn't matter whether you're using Hopper or IDA or Radara. You can load it and you can work with it. These are GNU-LD symbols, which is another format. You just have the name, an equal sign, the address, and then a semicolon. It doesn't get much simpler than this, but by keeping them in this format, you can then parse these files. So as we'll see later, I have a tool that runs through and identifies from the known address in one version of the firmware, it will convert that address and then find the equivalent address in a different version of the firmware in order to automatically port my linking symbols. This way, I only load the one version that I'm most familiar with into my reverse engineering tool, and never the other versions that I still target. Because I'm working with it at a function level rather than an instruction level. So we don't need or even want a shared database. There's no reason why I should have every one of your IDA objects as I'm editing the same project. Instead, I should only see the pieces that I need to see at that moment. I can load in all of your guesses if I want to find something new, but I should only link against your facts. So the linking file and the guess files can be held separately. In this way, we don't have to interfere with each other as we're working on the same project. We'll then need test cases to keep us sane. You need to make sure that the addresses are unique, especially in your fact database. There's no reason why we should ever have the same function referred to by multiple names. Test cases can run through and identify that stuff for us. Binary Ninja has an excellent headless mode, where in your Python script you can just import Binary Ninja and then have access to all of the different features that it supports. You can load up 2 firmware images, you can then import symbols to them and then compare them, all from an offline script that's run by a CI server and never by an individual human. So that you never have to open the GUI to validate that someone else's work is safe to import into the main branch of the project. And again, Mimine is my cat, Zepsitza. Now, portability matters, and it matters a lot. In the same way that we cared about teamwork, not for like fuzzy feel-good reasons, but because that allows more than one reverse engineer to work on the same project. Portability allows one reverse engineer to work toward multiple targets. Whatever you're reverse engineering, unless it's historical, there will be new versions of it. The radio firmware that we patch is under active development. They keep releasing new versions. So a workflow that's particularly effective is to work on one concrete target. So you have the one version that you're going to learn everything about. That's the version that you maintain your guesses for. That's the version that you become familiar with. And then, as much as possible, you automatically port that to different targets. And you use continuous integration tools. You use unit tests to verify that this is working. Some symbols cannot easily be ported over automatically, but the vast majority can be automatically ported if they haven't significantly changed. So rather than having the effort to like manually go through and identify all of these, you can then only identify the ones that the automated tool was incapable of handling. So this is a set of symbols for version 2.034 of the Titera MD380 firmware. And you note at the end that there are these comments saying that there's so many bytes of a match. This comes from a very simple C program that I wrote. It's only 2 or 3 pages in source code. But it's able to ignore the linker relocations in a thumb binary in order to identify which functions are identical to each other. It's nothing like BinNavi or related tools. It's not able to identify the individual blocks within the image, but it doesn't need to. All it needs to do is identify functions that are identical, because that's enough to port the symbols over. And the few that it misses, the functions that have behaviorally changed, those can be filled in manually. And for porting an entire version, it might be as few as 3 or 4 functions that need to be manually identified. So that I can then take the symbols for version 2.034, and my tool will automatically have them for 3.020. All with very little code, with very little time, and most importantly, with no manual intervention. This runs entirely through shell scripts, Python, and custom C, with no reliance upon any commercial software at all. It was written just for this one project. It's not portable to every target you might ever have, but a tool doesn't need to be that generic. It can be part of the build chain for your individual target, especially if you're trying to collaborate with others or to build up a reverse engineering result that can be read by other people or read by other machines or built by other people. So not all targets have full coverage, but unit testing will show you the gaps between them. And if you don't link against a symbol, you might not care that it's missing. There are plenty of functions that I knew the location of a long time ago in older versions that I've lost in the new versions. But if I'm not actually linking against that symbol, hooking it, or replacing it, I don't care. I can skip by it. And again, Mamin is my cat. Tsitsamvan? Is that correct? Now, you also need to care about completeness and scope. So scope is always controlled by your end goal. Are you trying to patch your target? In which case, you need a few symbols, but you really need those symbols. Are you trying to copy it? In which case, you might need to know all of the behavior of the target, but only the things that are difficult to reproduce, like the central algorithm of it. Are you doing this for a capture the flag competition, in which case you might have very little code, but also very little time? Or are you doing this for preservation, in which case popping the copy protection and allowing the old game to run in a modern emulator might be the only goal? You should also be clean in everything that relates to your final goal. You should maintain a clean environment so that anyone else who wants to get involved is able to without undue effort. The standard that I use is if a smart friend of mine wishes to join my project, how long does it take him to catch up and to be able to productively contribute to the project? If it's an hour, it might be very easy to trick a friend of mine into helping out. If it's a month, it's probably too hard unless he's being paid for the trouble. And this matters. This matters a lot if you want a project to continue. And every reverse engineer sort of starts with a mess and then has to clean it up. There's no reason for you to make this worse for yourself or to do your work in a way that cannot be maintained or ported to a new target. And again, Mamin is my cat. So you should treat reverse engineering like a development project rather than like an IDA puzzle or a Sudoku puzzle. It's not something that you're going to throw away at the end. So you shouldn't treat it like that. Instead, you should build it as something that can be maintained. Use text files and scripts for everything. There's a reason why, even in commercial software development, they've completely abandoned the idea of like an impossible to parse project file. You want your code to be as simple as configure, make all. You don't want to have to find the exact version of Visual Studio and then change the icons to no longer be in the My Documents directory. You should make it easy on yourself. And the ability to do this teamwork comes from version control, not from magic plugins. There have been plenty of attempts at allowing IDA to be collaborative, and none of them have really worked out. And I think the reason for that is that the tool is fundamentally designed for one operator. Anything that you want to make collaborative needs to be outside of that tool as something that you can maintain and that the developers of your project can individually understand. And through portability and testing, you can keep from fooling yourself. You can make sure that things don't break and that the pieces that you understood yesterday, you continue to understand tomorrow. And if it can't be tested, if you think that it can't be tested, the truth is that you're just too lazy to write an emulator. If you're going to all the trouble to reverse engineer something, you can go to the trouble to get pieces of it running in simulation. There are simple Python scripts that will emulate any microcontroller. QEMU can handle all modern high-end architectures. anything that Linux can run on, you can just compile an executable for that and then run it locally in emulation as if that were your main machine. Embedded ARM code runs fine in an ARM Linux process inside of QEMU on a modern x86 laptop. And cleanliness really is next to godliness. Like, keep your scripts clean, have scripts to parse all of your data, and keep everything in flat text files so that you can rebuild it in a new reverse engineering tomorrow if you have to. I'm out of time, so I will end with a picture of a cat. Thank you kindly for your time and attention, and I'll be around the conference if you have any questions.